How to operate the oscilloscope. In this video clip, we are going to explain and demonstrate how to operate the oscilloscope. After the demonstration of the oscilloscope, we will introduce the scope simulator on the computer, which you will use in some labs. Introduction. An oscilloscope provides a graph of an input voltage as a function of time. Display of the input voltage. On this graph, the voltage input is a sine wave. The y-axis is the voltage axis, and the x-axis is the time axis. Quantities measured. Using the oscilloscope, you can measure the amplitude, the time period, and the shape of the signal. Demonstration of the oscilloscope. Here is the oscilloscope you will be using in the lab. At first glance, you may feel it is difficult to operate because of the many buttons and knobs. But there are only a few buttons and knobs we are going to use in the lab. The front panel is divided into two areas. The control area on the right and the display area on the left. We use the buttons and knobs on the control area to obtain the best view of the graph. Let's turn on the power switch located on the top of the oscilloscope. Input connection. The signal to be measured, called the input voltage, is connected to channel 1. The input voltage from channel 1 is displayed in the current screen. Position controls. The vertical position knob moves the waveform along y-axis. The horizontal position knob moves the waveform along x-axis. Vertical scale. Volts per division knob selects the size along the y-axis. One vertical grid is representing a certain amount of voltage. You can find this value at the bottom left corner. Horizontal scale. Seconds per division knob selects the size along the x-axis. One horizontal grid is representing a certain amount of time. You can find this value at the bottom center. Measurement of the amplitude. First, you measure the number of vertical divisions from peak to valley. Then, calculate the number of divisions times the scale factor divided by 2. It gives you the value of the amplitude. Measurement of the time period. First, you measure the number of horizontal divisions from peak to peak. Then calculate the number of divisions times the scale factor. It gives you the value of the time period. Calculation of the frequency. You can calculate the frequency of the observed waveform. The frequency is the number of the waveforms within 1 second. Thus, the frequency can be calculated by this equation. Scope simulator. In some labs, you will use the scope simulator on the computer screen. The scope simulator is almost the same as the normal oscilloscope, except it works on the computer. Let's look at the screen. This is a window for the scope simulator. Again, it plots the voltage input on y-axis relative to the time on x-axis. In the scope simulator, you can move the waveform only along the y-axis by clicking these vertical arrows. These vertical arrows select the grid size along y-axis. The amount of voltage for each vertical grid is shown next to the arrows. The horizontal arrows down here select the size along x-axis.